So, what is the air resistance of the projectile motion? Air resistance can have a significant effect on a projectile's motion, especially if the motion lasts for some time. When the projectile is small and its speed of projection not too large, the air resistance can be modeled as a force opposing the motion and proportional to the velocity of the projectile. So, what is the air resistance of the projectile motion? Air resistance can have a significant effect on a projectile's motion, especially if the motion lasts for some time. When the projectile is small and its speed of projection not too large, the air resistance can be modeled as a force opposing the motion and proportional to the velocity of the projectile.
Projectile motion is affected by both the x direction and the y direction, so this means it has the same height. If you cut in half the parabola, it's the same distance on one side as on the other. Projectile motion without air resistance means it has no velocity. Projectile motion with air resistance travels more in the first half of motion than in the second half of motion, because as it moves forward, the velocity is being slowed down by air resistance. Both the range of a projectile and the maximum height that it reaches are affected by air resistance. The diagrams show how generally air resistance affects both the trajectory and the velocity of a projectile. The blue lines show the projectile with no air resistance, and the red lines show that what happens when air resistance is taken into account. The maximum height, the range, and the velocity of the projectile are reduced. To understand it a little more better, an example where projectile motion with air resistance is applied is when a basketball player throws a ball to the basket. He does not take a seat and make the mats in order to throw. He just connects his entire body and mind to determine the force that is needed to be applied, depending on the distance where he is standing from the basket. In a matter of milliseconds, he just takes a look to the target and throws the ball with the appropriate force in order to score. So, in conclusion, projectile motion can be part of our daily life activities. Therefore, understanding it is very important. To understand these two concepts better, the projectile motion without air resistance can be separated into two components, x and y. As Isaac Newton proposed, an object in motion will remain in motion unless an external force acts on it. This means that a projectile in motion will remain with the same initial velocity on its x component through its flight. When it encounters air resistance, it will change its trajectory because the projectile will have negative forces in both axes acting upon it. Therefore, when considering to launch a projectile, air resistance must be taken into consideration in order to reach the target properly.